Hi everyone, this is Steve Christensen. Welcome back. Today we're going to talk about the water treatment plant operator. Well, look at that water. I don't think I'd want to be drinking that. We know we have many water sources that are not directly suitable for drinking. Actually, over 99% of the water on this earth is not suitable for human consumption. The water operator is responsible for the health and well-being of their customers. Operators operate treatment plants to produce safe and pleasant drinking water. You know, through the years, I've tasted a lot of water, and I remember even when I was a kid, it wasn't unusual that we travel around to different parts of the country, and, we'd actually get sick from drinking the water, and it's because of standards. They're very different all around. But, we've got all different types of systems. We have a lot of technology. We have small systems, and we have large systems. Every system's different, and that's one of the things I want to emphasize. So an operator's responsibility is to produce safe and pleasant water, free of disease-causing organisms, free of toxic substances. It should not have a disagreeable appearance, should not have a bad odor, and it should not have a bad taste. So what are we treating in the water? Well, turbidity and total dissolved solids, TDS. Because those actually can harbor potential pathogens. Coagulation and flocculation, what is that? It turns fine and light particles into larger particles to aid in the sedimentation and filtration process. Sedimentation is a slow-moving tank that allows the settling of the floc then. Those groups that have coagulated and all stuck together, they gain weight and they float to the bottom of the tank. And then we have filtration, and the filters filter out the remaining suspended particles. So we take water from the source, and we have different sources. We have two very distinct types of sources. We have surface water, and we have groundwater. Surface water certainly is lakes, rivers, creeks, all that good stuff. And then groundwater is wells. Oftentimes we pre-chlorinate to assist with the post-chlorination processes. Again, we want to disinfect this water. It passes through a series of treatment processes. It flows through tanks and chemicals are added and mixed. And you can see these big paddles. Those go ahead and mix in the coagulant and the chemicals to go ahead and make that start forming floc. We've got all kinds of mixers, but they're generally paddles or something that's going to be slow moving. They flow slowly into a larger tank, and they group together, and then the particles settle out. They go to the bottom. You can see these weirs, and these weirs, they're notched weirs. And so the idea is all the heavy stuff's going to settle down to the bottom, and the nice clean water is just going to trickle over these V-notched weirs and go on out into the next part of the treatment plant. So, here we're looking at, basically a cutaway of some filtration. We've got anthracite and granite and coal and gravel and, many different things. We have mechanical straining of raw water, and large particles become large and cannot continue downward through the media. And then we have adsorption. Absorption of the raw water. The particles stick to the media and cannot continue down through the media. We add disinfectants. Chlorine is by far the most common. We have three types of chlorine. We have the liquid bleach type, which is really just, it looks like it's basically Clorox, what you get in the shelf, except it's a little bit stronger. The stuff you get in the store ranges from 2 to 7% consistency as far as the percent of solution. And the stuff that we use in the water industry averages about 12%. So you can see it's certainly a little bit stronger. Then we have calcium hypochlorite. That's the white powder, or it can come in discs or pucks. You often see that added into spas. And then the third type of chlorine we have, and that's normally about 65 to 75% purity. And the most pure we have is chlorine gas, which is also the most dangerous. It is 99 point something %. So other things that the operator is treating, corrosive water. Corrosive water deteriorates metal pipe. Here you're looking at some copper and you see the holes in it. But, we deal with the pH quite a bit. pH scale goes 0 to 14. Neutral is 7. Ideally, we're going to have slightly acidic water at about 6.8 is the ideal place. But if you look at this graph on the right-hand side, you can see, the battery acid, obviously, is on the low end, highly acidic. And you go up to the top end, look at the soaps and the seawater, and, it's kind of interesting. But you look at the right in the middle at 7, pure water, 7. Other things that we're treating, we're softening the water, we're removing the hardness caused by calcium and magnesium. I don't know if you've ever gone and washed your hands at somebody's house, but the soap just didn't seem to want to come off, or you were in the shower. And that's a sign of too much hardness. So other things that the operator is treating, iron and manganese. Iron and manganese are natural or occurring in the earth. It's colored water and stains the plumbing and clothing. Iron bacteria, taste and odors, stains plumbing fixtures and clothing. Treatment plants come in all sizes. Here's a small little standalone unit. And one of the futures of treatment is these little individual units that are actually going to be quite smaller than this for residential use. You're eventually going to see residential miniature treatment plants on all homes, period, with some disinfection, some kind of filtration. In the rural areas, there's a lot of good water that comes from wells. But again, that's changing. A green sand filter is the most common type of filter. It's a special type of sand they call green sand, and it's a gravity filtration. So it's a very slow process of the water going down through it. It's not highly efficient as far as the volumes, but for operators, it's a very simple system because it's a gravity flow that goes down through the system. You often see these systems normally on small water plants. There's another one. And again, Culligan, I don't know if you guys know that name, but they are really big in the water treatment business. And they were around even when I was a kid. We used to have a water softener when I lived in the Midwest. So we had very hard water. And the Culligan man would come around and actually bring us bags of salt to put into the softener. So this is a small treatment plant. And again, one of the things I want to point out here is you've got your filter over here, but you also have your chlorine injectors. And you see that there's 2 of them. That's because water redundancy and redundancy in systems is really important, because if you run out in one, it automatically has a switchover module that goes to the next one. And obviously, that's part of the responsibility of the water treatment plant operator. Chemical feed systems, these are diaphragm pumps, and they dial in and basically pre-measure into that. And again, a lot of it is digitized at this point, but it basically defines how much feed is going in, mixing the chemicals. So we've got all different types and sizes of plants. We've got plants that literally treat in the cities. And these are some pretty big plants if you look at these, thousands and thousands and thousands of gallons. The way they're normally measured is million gallons per day. So, the plant on the right, that could be a 50 million gallon per day plant very easily. Then you look at the really big ones, and this one's in Philadelphia. And look at this. This is the 5 or 6 story building here. So again, that gives you the idea of the scope of a large system like that. So what is an operator's usual task? He or she adjusts the flows according to the raw water conditions, adjust the flows according to the system demands, watch various treatment processes, maintain and repair the facilities as needed, and monitor or sample the raw water and finished water as needed. There's Mrs. Jones. She complains all the time. And you know what? we have to pay attention to her. Because the one time we don't pay attention to her, it's probably going to be the time that's going to bite you. But anyway, your customers are the ones that pay your salary, so you always want to respect them and treat them with dignity. And again, some of these people, unfortunately, sound like broken records sometimes. But when you go ahead and record a complaint, you want to know the who, the why, the when. You want to get as much information as possible. And you always want to make sure that you thoroughly investigate the complaint. You notify the customer lodging the complaint of the findings. A simple follow-up phone call. Hey, Mrs. Jones, we looked and we didn't find anything, but we certainly are monitoring the processes. And then you notify the customer of corrective action. Well, we found that it was a little bit too hard, so we added some additional chemicals to soften it up a little bit. On and on. Job opportunities. Huge in this industry. 10,000 jobs in the next couple of years in California alone. You have population growth. The baby boomers in this industry are retiring. There's a huge skill gaps between the old-timers going out and the new youngins coming in. And so in this opportunity, there's 5 grades of distribution as well as treatment. With what you're taking in this course, you're going to be able to go ahead, theoretically, test through grade 2 on both treatment and distribution. Now, once you get a couple years in, you can go ahead and become a grade 3 operator. And when you become a grade 3 operator, you're making it. If you go to work for in one of the cities as a grade 3, a stationary engineer grade 2 operator, which is only a grade 2 for the city of San Francisco, starts at $98,000 a year plus as much overtime as you can work. Oftentimes in the cities, when you get to be a grade 3, you're knocking down $150,000, $160,000 a year plus huge benefits. So one of the things happening too is with regulation ramping up in technology, the treatment is becoming more sophisticated. Water certification regulations are continuing to tighten up. I continue to see through the state these tests keep getting harder and harder. What used to be on grade 3 tests is now on grade 2 tests. What used to be on grade 2 tests is now on grade 1. And the regulatory requirements. Who knows what's going to happen in today's political climate right now? But with that being said, we've certainly been on a trend tightening up regulatory requirements. So there's a lot of opportunities. There's actually well over 100 job descriptions for the water industry. It's changing rapidly. Workers are hired by cities, towns, private industry. Even all the wineries now are starting to hire water operators. They're needed everywhere, from the mountains to the sea. Oh, by the way, you can work on a cruise ship if you want to. You can go work in Tahoe, you can go to Alaska, or you can go international if you want to. The pay, well, it depends. If you're in rural America, it's certainly going to pay a lot less than if you're in the city. So what does it take? Your hard work and desire. We have the ability to go ahead and help you get certified, so that's what we want to do. And for qualifications, it depends on how far you want to go. You can make a very good living just going through, and becoming a grade 2 or grade 3 operator without a lot of additional education. Or you can get a 2-year degree in water resources management from Columbia. Or you can go ahead and get a 4-year degree, become a civil engineer. Or you could become a hydrologist. You could go ahead and get an MBA, and there's certainly PhDs. So it's, again, depending on how far you want to go, it's your option. And it's just depending on how driven you are and what you want to do. So thanks for joining me today. There's a quick overview of what a water treatment plant operator does.